scatter graph. We've got two linear functions here. There's a linear function here, then a linear function here. This is piecewise linear functions. I just want to show you how to draw a function on here with a restricted domain, so for 0 to 3 minutes on the x-axis here. Menu, analyze, plot function. So I think we said this was a 10x, y equals 10x, right? Because it was 10 cents for every 1 minute. Yep, I think that was right. But then we want to restrict the domain. So it's in this little control bit here. Look, control equals opens up this menu. And it's this vertical line. This kind of says, I want to plot 10x given the following conditions. So I want to plot 10x subject to the following conditions. And in here, we're just going to type in the domain over which we want this 10x to apply. So we want 0, and then control equals again is less than or equal to x, the variable. And then in here again is, oh, I got the wrong one. Let me just delete backspace. I need to do control equals. There we go, that's better. Is less than or equal to 3. All right, so if we put that on, and there it is, can you see? We've got that nice little bit here. All right, so let me just get that up here. And that's nice, eh? So now you have to work out the equation for this here. We worked it out in class today, but I want you to try and work it out again. I'm going to go ahead and type it in just to show you how it works on here. Menu, analyze, plot function again. And I think this one was 5x plus 15. If we press enter, can you see it? It's correct, but it has all this extra bit here. We don't want it to apply for the first 3 seconds, so double click on it, and we can just go to the end and modify it. Control equals given that. Now we want all the x values bigger than 3 minutes, right? So we're just going to put x, and we're going to look at the greater than, which is there, greater than 3 minutes. Press enter. Boom. Okay, so it's kind of this. See, it doesn't join up very well here with the pixels, but you can see the idea. We've got two functions working together. Now, if you have a little look on here, click, this is F6, and click, this is F7. So we're going to do something fancy now. Doc, insert a graph page, and in here I'm going to type in F6, open bracket X. Okay, which is good. Now if I change the axes, I'll just go from -1 here. Remember, this x-axis was the time. We'll go up to 20. And then the costing up here, let's go up to 200. Okay, so there we go. There's the first bit of the graph already there. And now if I do Control G, shortcut to plot the graph, I've already got F6 of x. I'm going to type in F7, open bracket, close bracket, x. Fantastic. So look, we've just transferred from our scatter graph here with all the points onto a just a normal graphing page. Now this is going to be useful because if we plot another line on here, so let me just plot another line on here, Control G. If I plot, let's say, I don't know, let's do 7x minus 20. Right, so this is just a random line I've got on, but can you see there's an intersection point here? And I could find that by going Menu, Analyze Graph, Intersection, choose this graph with this graph, then choose a point before and after, and there you go. These two graphs intersect at 17.5. That's the x value. That would be 17.5 minutes, and the cost is $102.5. Okay, so that's going to be useful maybe to answer the last part of the question given.